Okay, so now it's 9 a.m. in one part of the world, 4 p.m. in my part of the world. And I want to welcome all participants to the Ars International Committee event. Today, the event title is International Grant Success Stories, Unlocking International Collaborative Research Opportunities. And we have two wonderful speakers. I want to welcome Associate Professor Won-Yon Park from University of Southampton and Professor Emerita Judy Dori from Technion, Israel Institute of Technology. And I want to thank Dr. Arif Rahmatullah from the CRA International, who is collaborating with me in this session. My name is Shuli Abergil, and I'm from the Technion, Israel Institute of Technology. I also want to welcome all participants who registered for this event. I don't know if all the people who register are here today, but I want to show you that we have a diverse presentation from people who register. So we have here organization and institution from around the world. We have representation from Australia, Philippines, India, Turkey, Africa, and United States, Chile. So I welcome you all to this event, and we're very happy that scholars from around the world decided to register and participate in this event. I don't know if Arif joined us. Arif, are you here?
I'm here, Shirley. You can
Hi.
just keep going. Hey,
Okay.
hi everyone. Welcome.
Hi, Arif.
Yeah, can I just say hi to everyone, please, also?
Yes, go ahead. Of
Okay.
course.
Well, I want to thank Sherry and Arif for organizing this. And the speakers, I say a big thank you for your time in preparing for this. We hope we're going to all have an exciting session. I'm the international coordinator. Thank you all.
Okay. So this was our little of introduction, saying hi to everyone and welcome you all from around the globe. And I'm gonna move toward our first presenter. Just a second. Okay. So our first presenter is Won-Yon Park. He is an associate professor of science education at the University of Southampton. His research focuses on the intersection of science, humanities, and society and education, particularly the role of science and STEM education in promoting social justice during local and global crises. His projects have been funded by organizations such as the Economic and Social Research Council, Research England, NSF, and UNESCO. He collaborates with institutions worldwide, for example, the University of Oxford and Seoul National University. So I'm going to stop sharing my screen, and please share your screen, and I'm asking everyone to put on mute. After the presentation, we'll have a few minutes for some questions. So, Won-Yon, the stage is yours.
Right. I'm hoping that everyone can see my slides now. Shirley, can you confirm? All right, that's excellent. And I'm thinking Jenny's microphone is on. So okay, thank you, Jenny. All right, so hello everyone, and thanks Arif, Shirley, for inviting me to this event to share my experiences, especially at this historically important and difficult time for education funding and grants. My name is Wanying Park. I am an associate professor of science education here at the University of Southampton in the UK. So just to say a little bit more about me, I originally grew up in South Korea, and I trained as a science teacher, and I did my undergrad and master's degrees there in science education before I moved to the UK 7 years ago for my PhD. And I have been working on my job for, this is my 4th year. So I also collaborate with colleagues in the United States, East and West Coast, and other countries, Europe and other parts of the world, and some of which I'll be talking about today. So in terms of what I research, Shirley already introduced some kind of broad overview of my research areas, but I was first interested in nature of science in science education, and particularly how science and technology are intertwined and interconnected with society, politics, and culture, and so on. And that was what I did my PhD on. And my PhD was 4 years ago, and since then I have focused on the idea of my second theme of research, which is the idea of disasters, whether that's natural or technological human-made disasters. So I've been focusing on the idea of disasters and try to link and relate disaster theories to science education, which is the part of the work that I will be focusing primarily on in today's presentation. I'm also interested in my sort of how science education policy is made across different contexts, which also kind of involves lots of international collaboration, because if you want to understand how science education policy is made in one country, a lot of times you need to understand how it's done in other countries as well. So again, for the purpose of this talk, I'll focus on how I have used grant opportunities to develop my research in the area of disasters in science education. This means that today I am mainly speaking from the perspective of an early career researcher who's pretty early on their career trajectory. So these are the great people that I have had the privilege of working with as my work in disaster and science education has developed over the last few years. So less than half of these people are actually science educators. I have worked with people who are history educators and ethics educators and non-educators. I've worked with historians and anthropologists of science and technology and environment, which I enjoyed very much. And I've been connected to most of these colleagues through different grants that I have worked on. So I'd like to open with talking about some of the challenges that I have encountered personally when it comes to international collaboration in science education research, and more specifically, grant applications. So the question is, I mean, why do we even need international collaboration? Do we have to internationally collaborate for science education? And what do we hope to get out of that collaboration, right? So one of the biggest hurdles that I have observed is that how research grants work is very, very different across different contexts. So what counts as a very strong proposal in one place might not even make it past the first round somewhere else. And then there's the question of who reviews the proposal. Sometimes there are science educators who know about this topic that you're talking about and proposing. And sometimes, more often in some countries, it is just generic education people, in which case you don't want to be too specific about science education theories and terms and concepts. And then sometimes they're just generic social scientists who are reviewing your proposal. So that is, I think those are really important considerations when you're pitching your study and research. And these things make a huge difference in terms of how we frame our work and how we present and pitch, and what kind of language do we use. And there's obviously the unspoken and unwritten rules. Sometimes funders might say they welcome all different approaches, but in practice, all they fund is quantitative experimental RCT type of studies. So that happens quite a lot of times. So all of these things actually make international grant collaboration is pretty challenging, and there's a lot more to consider when you're just focusing on one country's context and applying for national funding. And beyond these sort of logistical and procedural issues, there's I think there's a deeper issue, which is that science education research is often very specific to national context. So what we choose to research heavily depends on how science education is organized and how it is practiced in our own context. And sometimes it is hard to find a topic and a focus that can work and is meaningful in multiple countries, because their education are very, very different. So I'm going to now talk about how my first grant happened. So this started in the summer of 2021 when I had a job offer from my current workplace. And then, but I was still kind of finishing up my PhD. I hadn't even moved to this new place. And one of my friends from Oxford, where I did my PhD, who was a postdoc there, sent me this link. And my friend was just saying that I saw this somewhere and you might find this interesting. So that was all she said. And she was not even a science education person. She was just my friend. So I absolutely had no idea about what grants were and what they meant. So I asked my new colleagues at Southampton, new 2B colleagues at Southampton, if I could apply for this or if I should apply. And then what they said was, yes, go for it. And I went for it and we were selected. So, and as you can see, this was very specific kind of networking, international collaboration grant, which sometimes we do see, but, you know, specifically UK and South Korea, both countries that I know a little bit about. This was the first and last call that they had, at least for humanities and social sciences, for those two particular countries. So in this project, we were a team of 11, and there were only 2 colleagues actually from my own department, bearing in mind that I had just started at my university. And when I decided to focus on disasters, we thought that it might be worth approaching the environmental science department at the university to see if they had anyone interested. And we had a colleague, Craig, who is on the slide. And like I said, it was a very specific international collaboration, so I had to reach out to some Korean institutions and colleagues. And first, I reached out to colleagues that I knew before who were science educators, but also I reached out to people I didn't know but wanted to kind of work with based on my reading of their work. This is sometimes tricky and risky thing, that to reach out to people that you haven't worked with or you don't know well. But if you know there's a fit, I think it's worth trying. And these group of colleagues are mainly, they're not educators, they're mainly historians and anthropologists and sociologists of science and environment. So one of the things that we did in this project was to organize conferences and summer camps focused on disasters and science and society broadly. And in these events, we invited researchers, disaster-affected families and communities, and activists to these, so basically connect with them and learn from them, and sort of based on our individual experiences to shape collaborative and communal learning that had a strong educational element. These events were educational, but we also had a chance to reflect on how the role of education in recovering from, preparing for disasters in very different contexts. So, and more specifically, the grant, what it allowed us to do were, for example, we organized symposia at NARST and ISERA focused on disasters and science education. They were not exactly identical. And each time we invited people from outside our project to broaden the network. So we're doing this symposium, we're organizing this symposium on this topic. Oh, I noticed that you're doing similar work. Do you want to collaborate, and do you want to join the session and sort of learn from each other? And a lot of people, as long as they are coming to the conference, are happy to do that. And I was able to visit different places to learn about how disasters might relate to science education in that particular context, a particular national, regional, political context. And we have also been able to put a lot of what we've learned from the project into a journal special issue that is coming out soon, focused on disasters in science education. And research and idea-wise, what we have achieved in this project is there were some new and original ideas that we were able to develop from the project, such as STEM education for disaster justice. So we were able to some extent, conceptualize this from merging and sort of synthesizing our work coming from education, environmental sciences, and history of science, and sort of philosophy of technology, and all of these. And we were able to consider disasters in the global north context. And the reason this is important is a lot of work in disaster education or disaster risk reduction is actually focused on the global south context. So we were able to develop some ideas because of the status of those two countries. Lots of disasters that we focused on were more industrial, human-made, technological sort of disasters. And lastly, we developed the idea of cross-curricular collaboration between different subjects. So how science educators can work with other subjects to facilitate a holistic and complete understanding of disasters rather than trying to do everything by ourselves. So one thing that I was able to, and I was lucky to do with this grant, was to host my friend Noemi Waite, who's an associate professor at the University at Buffalo in the US, whom I knew from NARST Sandra Abel Institute a few years before while I was a doctoral student. So she actually visited us in Southampton in October 2022, which is during this project. And then she gave us a seminar on her work based on community assets with historically marginalized groups of people in the community of Buffalo, which had a significant overlap with our community-based approach to disaster justice in our project. So while she was with us in Southampton, we discovered this book about a blizzard that hit Buffalo in 1977. And how it kind of contributed to the creation of FEMA, that's Federal Emergency Management Agency, as well as some of the other disasters in Buffalo, such as the Love Canal disaster we talked about. We explored this idea. And then just under 2 months later, around Christmas of that year, what happened was there was another severe blizzard that hit Buffalo for 4 days, which ended up killing over 40 people in the city of Buffalo. So, and as is often the case, certain groups of people died much more than the rest of the community. And the blizzard ended up exposing many inequities and injustices that are already there, that the authorities knew about but chose not to do anything about. So a lot of deaths were actually concentrated in the area, in the part of the city that were racially and economically marginalized. And you can see in these maps the racial and social and economic segregation that made certain demographic groups much more vulnerable to sort of climate events and disasters than others. And so it's not really the extreme weather events themselves that are killing people, and it is instead the social conditions that made people live in certain areas of the city and made people have to go out in the snow to get food. And this is the FEMA disaster risk map, and it is currently down because of the government action, which is very unfortunate. So after reading about this and hearing about this, I contacted Noemi and said, hey, we should really do something about it. And then we found out about this rapid response scheme from the National Science Foundation, which is to support quick response research following natural or anthropogenic events. So to what extent the blizzard was natural or anthropogenic, or is it worth trying to distinguish that, is a different question. But anyways, we contacted a program officer who gave us some clarification on what this scheme was for and what they were looking for and what are some of the criteria in there, which is really, really helpful. So we decided to go ahead. And one challenge that we particularly had for this one was this part of the NSF funding policy, where they rarely provide direct funding to co-PIs based outside the US. So I'm obviously based outside the US. So unless there is bilateral funding coming from the partner country, right? So unless the UK government is also happy to provide some funding, and we just didn't have a mechanism or time to actually arrange that. So, and this project was heavily based on the Buffalo context. So I think it is a fair question that why do you need this guy from the UK to actually study this? So we needed to a very strong justification as to why someone from the UK is essential to this project. And what helped me really, at this stage was that I had already completed an international project, collaborative project focused on disaster justice and science education, which is reasonably unique from the point of view of this, from the point of view of science education and in relation to this Buffalo grant that we're putting together. So, well, long story short, we're able to convince the reviewers on this, and it shows, I think what this shows is that how one grant opens up another grant opportunity by helping you build your own agenda. So we received this funding from the NSF. It is still ongoing, which allowed us to visit Buffalo twice and interact with the families, teachers, and community leaders who are affected by the disaster. And from these interactions, we've been working to develop community-based climate justice curriculum framework based on the Blizzard memories and experiences that are responsive to the local needs and priorities. So this is my last slide. Just to conclude, as an early career science education researcher, grants have helped me to meet new people, explore lots of diverse perspectives, and also expand my research through new learning opportunities and research visits to different places. And many grant opportunities that I just talked about, they have emerged from previous networking activities, whether there are conferences, special interest groups, collaborative grants, and sort of summer schools, and all of which have played a really important role in shaping my research trajectory in the last few years. And working internationally has really helped me broaden my understanding of science education by really sort of allowing me to examine key issues such as disaster justice across really, really different kind of educational contexts and how it might contribute and make sense in different circumstances and contexts. So that's all I have for now. I know that I went over time, sorry about that, and thanks for your attention. I'd be happy to take any feedback or questions later.
Thank you very much. Won-Young, that was a great presentation and with a lot of information and tips about your collaboration. And I also think about how to move forward from grant to grant and meet people. So any questions from the audience to Won-Young before we go to the next presentation? One grave question. Maybe I'll ask something. Can you tell us what you learned maybe on a nutshell about different educational contexts in science education? I see that you have experienced a lot of countries and cultures. So maybe, I know it's a big issue, but maybe you can tell us a little bit about culture differences in science education from your experience.
That is a big question, Shirley. That is a very, very big question. But one thing I'm just going to share just an episode that I had when I was visiting an American school, when I was visiting Noemi in Buffalo, which was, so we were visiting a school, and then there was a, I forgot the exact term that they used, but there was a lockdown of the school while we were there. So, and that was very new to me, and that was very surprising to me. And then so I had to, my colleagues had to explain to me what this meant and why these things happen. And then that episode of experiencing these things, sort of like that, what's going on in American schools. Well, I'm not generalizing, but you know, it kind of shows one aspect of the complexity of education that is going on in different places. So, I mean, obviously, there's different security issues in different countries. And I think science education, one aspect that I think is quite important is sometimes I have to blame myself on this, but sometimes we try to understand science education and analyze science education as something that is separate from others. So something that is quite independent, but, you know, where science education is happening is schools, and teachers have 100 other things than teaching science. And so just trying to understand how school and education policy, whether that's school level, district level, national level, state level. So that just taught me a lot about the numerous things that I have to learn to basically understand what is going on in the classroom. And that is something that I only learned when I was exposed to a very different kind of foreign culture of schooling to me.
Yes, thank you for pointing that out. That is very important. And we have a question in the chat from Yael. Hi, Yael. And Yael is asking, can you tell us about the summer schools? What was your contribution and how this participation contributed to your project?
Yeah, so I talked about different types of summer schools in my talk, but one thing is that something that I organize as part of my project, but I think what Yael means is what I mentioned towards the end, and how my participation in summer schools as a student helped me build network. So if I can just talk a little bit more about that. I attended as a student NARST summer school, and which is called Sandra Abel Institute. And I also attended ESERA summer school that was supposed to happen in Oxford, but ended up in online because of COVID. But I think the summer schools, and also last year I participated in ESERA summer school as a mentor, which is a great experience. And then I think what summer schools do is compared to big conferences such as NARST and ESERA, where thousands of people just come and there's already a strong network of people all over. I think what summer schools can do is it's a relatively small group of people, and you're spending a week together with people from across the world working on, and you have opportunity to talk about your work and their work. So I think it's really kind of intimate and intensive kind of opportunity for you to network with someone. And then Noemi and I mentioned that we had met at a NARST summer school. She was a mentor and I was a mentee. She was not my mentor, but we kind of found some common interest in one of those summer schools. And then kind of we didn't actually do anything together until we started this project, having known each other for years. But, you know, I think one thing that I told my mentees during the ESERA summer school last year was, you know, whoever is in that summer school will probably be your colleagues or collaborators or your letter writers, or you know, lots of different things. I mean, so science education community, I think even internationally is, it looks very big, but after years, there's a lot of networking, and, you know, we work with each other. So I think those summer schools really provide that opportunity to connect with people in a little bit more intimate and intensive setting.
Thank you. Just to add to that, Yael, I participated in the first Sandra Abel with Sandra Abel, and that was an experience that boosted my career tremendously. So I really recommend joining those summer schools. And now we're gonna move forward for our next presenter, which I can say was my PhD advisor, and listening to her advice, I participated in the Sandra Abel Institute in 2010. So I'm delightful to present Yehudit Judy Dori. She is a professor emerita of science education at the Faculty of Education in Science and Technology at the Technion, where she also served as dean. She was a researcher and visiting professor at the Massachusetts Institute of Technology, MIT, in the United States. Professor Doris Riester was funded by various national and international grants such as the European Research Council, the Aberlof Initiative, MIT Microsoft iCampus Alliance, and the National Science Foundation. Her research focus includes science engineering education, chemistry education, scientific visualization, high-level thinking skills and metacognition, learning and educational assessment, online learning, encouraging girls to study science and excel, and promoting women to careers in science. So I'm going to stop my screen and thank you, Judy, for joining us. You can share your presentation.
Hello, everybody. I'm very glad to be here. It's an honor to share my experience with you. I have been in this research for more than 30 years. So I also won the 2020 DCRA NARST Award. So my experience is very broad. You heard from Shirley that I have a lot of research interests, but not all of them evolved immediately. I started as chemistry educator, and after about 10 years, I moved to science and engineering education and so on. You can see in this picture my research lab. I just hope that my slides will move from, wow. Okay. You can see here, my group includes 4 senior researchers and 4 PhD candidates, and all of the PhD candidates are after candidacy exams. We are also responsible for National Teachers Center for Engineering and Technological Education, meaning that we are responsible for about 1,000 teachers who are teaching in high school, either engineering or technological learning units. We investigate STEM, cognitive, metacognitive, and assessment, along with career choice and retention, and 21st century skills. I would like to focus today on 2 examples. One project at MIT was TEAL. I'll elaborate in a minute, and it actually expanded from 2000 to 2008. And another one from the European Research Council, ERC, from 2020 till 2022, and the short for this project was TRACOD. In between, I received about 10 funded international projects, such as iGEM, it's a synthetic biology competition, Flipped Classroom at MIT. Both iGEM and Flipped Classroom was funded by MIT fundings. Mosaica and Visionaire were ERC projects funded by the European Council. So you can see that during my extensive research, I actually experienced both collaboration in US and Europe. I'll start with TEAL, which actually boosted my career tremendously. TEAL is short for Technology Enabled Active Learning. You should put emphasis on that. It started in 2000 when a technology was not so embedded in educational learning and assessment. We decided, you can see here Professor John Belcher, a well-known physicist from MIT. We decided together that we should do a long-term educational experiment. And his idea was that he would, at that time, he wanted to redesigned the freshman MIT physics courses. At that time, the physics courses included 700 students in one lecture hall for 3 hours per week, and then 2 hours lab, and not always the experiments in the lab had any connection to the theory taught in the classroom. We got fundings from many people, including Bill Gates, who supported MIT Microsoft iCampus Alliance, as well as later from NSF. I just want to mention that John Belcher was NASA Exceptional Scientific won NASA Exceptional Scientific Achievement Medal in 1990, and the Hans Christian Ørsted Medal of the American Association of Physics Teachers in 2016. The collaboration was based on the pedagogy and the research. Till classroom and course design are still going on. It's a project that still you can come to MIT and see the physics classroom the same way we designed them in 2000. Actually, they added one more lab like this. This lab can include 120 students per one session. And in order to enable 700 students, they had 6 sessions, depends on the days, and the interaction was between teacher and students to promote learning, interaction among students for peer teaching, more active learning than passive learning as in lectures, and hands-on experiments and simulations and visualization to enable the students to visualize abstract ideas in physics. This is just an example of a representation of the pre-post retention assessment that we conducted of student conceptual understanding. We had about 120 experimental students who studied in the Thiel classroom and about 50 in the control. One more thing about that, the findings were significant. We saw that the gain in the post was much more than in the control. This gap was narrowed in the retention about a year later, but still a significant difference. In the comments of the students, open-ended comments on the course, on the benefits of learning physics in traditional versus Thiel, the strengths of the experimental approach, the Thiel, was in group work, in student interaction, and visual and hands-on activities, as well as conceptual understanding. Our collaboration was actually between a science expert and a science education expert. We wrote together research proposal, the first one to Bill Gates, and then to NSF. We wrote it together. I wrote the theoretical background for the pedagogy, and I contributed the methods for evaluating whether and how the project affected the students. We were budgeted with several million dollars, including building the lab. The project involved systematic change at the university and included integration of advanced technologies. Due to the evaluation component that I was responsible of in the project proposal, we actually got funded much more than others because their evaluation was minimal while ours was very significant. The second example is TRACOD. TRACOD is a European funded project, short for Track the Codfish. Actually, there was a call for EIT food project, and we searched for collaborators. We found them, one in Iceland and one in Belgium. We actually use the capabilities of Iceland to track freshness and nutritional values of fresh fish. And we at the Technion used models to implement in the app that the Belgium startup developed. And the idea was to include an education component to teach the next generation of food engineers and teachers. The research objective was to investigate undergraduate STEM students and teachers, both system thinking and modeling, via a food-related online course. It was also during the COVID, so the online course helped many of the teachers to teach even during lockdown. The participants in the research were 28 systems engineering and 27 STEM education students at a top-tier research university. The main findings were that system thinking relative improvement in the engineering group was significantly higher than that of the STEM education group. When I say relative improvement, we use it in many of our studies in case that the pre-test or the pre-evaluation is very different from one group to another. So instead of just comparing pre to post, you actually use Hake equation. Hake was a physicist, and he showed that when you use relative improvement for groups that are not identical in the pre, you can better explain differences. So the relative improvement for the engineering group was significantly higher than the education group. The improvements were less prominent in modeling than in system thinking, but still in favor of the engineering group. Participants wrote in the open-ended feedback something like, the most important thing I got from the course is the ability to properly understand data and the ability to describe each process technically at different levels of detail. Or another one said, the aspect of modeling is very useful. This course not only gave me knowledge that would help me at work, but also gave me skills that would help me break down into elements the problems I encounter. In TRACOD, we have several challenges. We expressed interest in a call that was issued by EIT Food and wrote a short abstract explaining our focus and area of expertise. Then we attended a workshop in Italy and met with other interested parties. We found two partners from one, a research institute in Iceland, and another startup from Belgium. And we experienced several culture and work norms differences. For example, in Europe, they take the vacation during summertime, and it meant for them that 2 months they didn't respond to our emails at all. Sometimes it was language barriers because these countries not always applied to the research funding of Europe, so they weren't so, at least the ones we worked with, were not so well acquainted with other languages such as English. COVID-19 pandemic prevented all of us from visiting each other. I can tell you that in a project that I had earlier in Mosaica and Visionaire, that we could meet, the connection and the relationship was much, much better because of face-to-face meetings. So this was a real barrier for us that we couldn't invite them to the Technion, and we couldn't go to see them in their own countries, even though we had funding for travels. I would like to talk shortly on the collaboration benefits. First of all, you get funding for PhD or postdoctoral students. Then there is academic connections for sabbaticals and or short visits. We can continue the research. You saw in Thiel that even though I had a 2-year sabbatical at MIT between 2000 and 2002, I kept on coming for short visits and kept on the research until 2008. And of course, co-authoring articles, which actually boost my ranking at the Technion. Engaging in joint research, I wrote some tips. For example, search EU funding agency for science and engineering education. Seek open calls that are relevant to your expertise and interest. Participate in matchmaking meetings, like I mentioned in Italy. You spend 2 days in a very focused workshop, and then you meet new people. Summer school is also a very good way to meet new people. Join another, if you don't meet occasionally in meetings, you can join a senior faculty who has experience in international collaborations and use his connection or her connections to establish a proposal and together, and then find new connections for the future. When preparing for sabbatical, try to contact a colleague in the US or in Europe ahead of time, about a year ahead, and submit a joint research proposal. For example, with US, MIT MISTI is not only from MIT and Israel, it's for many, many countries who collaborate with MIT, and it offers only seed funding for short-term faculty exchanges, but then you can follow by submission of a follow-up proposal. These are the two citations of these 2 projects. Of course, I wrote with John Belcher a few more publications, and about TRACOD also 2 more. You can see the difference in citations, both because of time spent, but also because the Thiel project was something that was mimicked in many, many universities around the globe due to the innovation of the research and technology. I'm open to questions, and I'll stop the sharing.
Thank you very much, Judy. It was a wonderful presentation. I can say that I learned from both presentations that you need to be proactive in making connection, searching for grants, consulting colleagues about opportunities for collaboration. That was very strong in both Wanyan presentation and in Judy's presentation. And I hope to hear some questions for Judy specifically about her presentation. So go ahead. Okay, Judy, you talked about the funding and from the European Council, and you said you wrote a short abstract and then you went to Italy. So based on the short abstract, you already got funded, and or this
No, at the Technion there is an option that if you write an abstract and the committee that supports the EU projects choose your abstract, they fund your travel to Europe for a 1 workshop. in the workshop, people can see your abstract. If they came and they don't have an idea, but they want to join you, they will search you in the round table. Sometimes people publish their abstract like I did, and some others publish a similar topic. So then you go to their own round table and you say, hey, I have an idea similar to yours. Can you collaborate? So twice in my life, I went to once to Italy and once to France for such workshops, which is not for PhD students. This is for faculty in certain stages in life or in career. And then you can either join a senior faculty or a younger faculty, but as long as you find topic that can be based on one expertise in maybe more science and the other more educational technology, and the third one maybe in assessment, you can collaborate and write a full proposal and then get the funding. One other thing is like the summer school, there are sometimes like, we call it Gordon conferences. It's not as big as NARST or ESERA. The Gordon conferences are in US, and they are also specifically designated for either chemistry education or physics education or visualization, other topics. They have meetings once a year on this theme. And even if you are not a presenter, you can ask the organizer to invite you, even for a poster, as a PhD or a postdoc. And this is much smaller. It's like the summer school, and you meet very well-known and prestigious scholars that you can make connections for sabbatical, for short visit, etc.
Thank you for these wonderful suggestions. We have a question in the chat by Monica McGill, and she's asking, you mentioned searching for EU funding. Are there specific places to search that you would recommend?
I would like to recommend, for example, either the EIT food or in the EU, the sustainability, they call it sustainability and something else, I forgot right now. But the idea is that they are focused on both scientists and educators going together, working together. So most of the European who join these projects have strong either, yes, the Horizon, good. You are even more kind of like up to date with this. I stopped submit funding because I have big funds from Israel, and it's enough for me to work as an emerita. But Horizon has different topics. So first I look for the strand that fits me, and usually I manage to get funding either through sustainability or through EIT food, because they are more interdisciplinary projects, and they usually have scientists or researchers but don't have educators who know how to assess the benefits of the project. And both in the US and in Europe, the assessment part of the project is crucial to receive funding. They want to see that you have a method or a tool that you actually used it before, and you can expand it or modify it to fit the assessment of the project. So this is our strength as science educators, that we even if it's not your own tool, even if it's someone else's tool, but you ask the person for permission to use, let's say, questionnaire or a interview protocol or a focus group protocol, it doesn't have to be yours. It can be a tool that you read about. You, just for example, like a month ago, a colleague of mine read a paper I wrote on all the graduates of the Technion in the last 25 years. And I put in the paper examples of questions from the tool, but I didn't, added the whole tool. So my colleague said, I read the paper, I want to use this tool, would you be able to send me? And of course I sent her the tool. And of course she will cite our paper. So we both gain from it. So for the European applications and also to some of the NSF applications, if you don't have your own tool, but you know it can help boost your success, apply or ask from a colleague his or her tool to use in the proposal.
Thank you, Judy. So I think we just discussed all the questions that we have for discussion. So I'm gonna just summarize what we did today. I think we saw a lot of specific examples how international collaboration can enhance research. I think both presenters related to that. I think we got a lot of advice about how to apply to international grants, specifically being proactive and looking for those. I think both presenters talk about the success and the factor that contributing to their success in the international grant application, and also talked about the challenges. So I don't know if any one of the presenter want to add something, or is there any other questions? I see Lauren. Hi, Lauren, saying thank you for presentation.
And if anyone wants to ask more questions, you can use our email and send us, and we'll be. I'm sure I can talk on behalf of my colleague too. You can send us email and we'll respond immediately as soon as we can.
So thank you, Wan Young, for being with us and sharing from your experience.
Thank you, everyone. Thank you, Shirley.
And thank you, Judy, and thank you, everyone, for this wonderful session. I've learned a lot. I hope.
And thank you, Shirley, for organizing
I
it
also
together.
want to thank you.